Okay, question 11, the probability density function question. It's a continuous random variable, so I know that all of the stuff going on here is to do with the integration. And the first question asks me to show that A is zero point 0.1, B is zero point 0.2. So I use two bits of information. First of all, I know that the total area underneath this probability density function is going to be equal to 1. So I set up the integral between the limits of 2 and 0, set it to 1, and that will lead me to one equation, or number 1. The second bit of information that's given in the question then is that it tells me the probability of being bigger or equal to 1 is 0.675. So the method here that's taken, okay, so from 1 to 0 is 0.325. I think using the limits of 1 and 0 is slightly easier than using the limits of 2 and 1, but you could, of course, set up the area from 2 to 1 to be 0.675. Either way, that leads you to another equation relating A and B, and then to show the result, of course, is going to be solving those two equations. It's a show that, so you're going to want to show the steps of algebra to arrive at those two results. So that's the first part. Once you've got that, the other parts of the question are very much calculator heavy. Part B asked me for the expected value, so I put that straight into the formula. I write down the formula for my method, xf of x between the limits of 2 and 0. I've got that on my calculator. I can just punch that straight in to get 1.24. No more working out required. Similarly for the variance formula, integral of x squared f of x minus the mean squared. So write down the mathematical statement for your method, stick it in the calculator, and get your answer out. For D, find the median. Well, I know that the median is the value for which the area between the median and the bottom end, so 0 in this case, of the function is a half. Now, on the calculator, again, you can get the calculator to do all of that for you. I've got it here on my calculator. I'll just show you this. The command in the calculator, numerical solve integral between m and 0 of the function with respect to x 0.5. Solve that for m, and it tells me the answer there. So again, there's no working out. I think there's a typo here. That was 1.371. So 1.37 to 36 fig. So, as I say, very calculator heavy. Question E, it then extends the question to say, okay, 10 independent observations of X. And Y is the number of observations. So the thing to realise here, Y becomes a binomial variable. 10 fixed trials, probability of a success on each one is 0.675, so I've got Y as a binomial variable. So for E, find E of Y, the expected value of a binomial variable, NP. So there's my answer. And then the last question, less than 4. Of course, now binomial is discrete. So less than 4 is less than or equal to 3. And of course, I'm going to use my the binom CDF function on the calculator with the appropriate parameters to get the appropriate result there.